Good day to all. Welcome to our class in Biostatistics. I am Bert Kian Pograd, your instructor. For today's instructional video lecture, I'll be discussing data and the different forms of graphical presentation. In order to facilitate the interpretation of the data, this should be organized and summarized through frequency distribution. The data can also be presented with the use of different forms of graphical presentation by means of histogram, frequency polygons, and ogive curves. The primary purpose of graphs and tables is to visually display the information or the data or the information that has been that has been analyzed in a manner that makes easy for the readers to comprehend the information. One way in presenting the data is the use of tables. In building a table, we need to know first these different concepts. First, we have the class interval or class limit. We also have the class mark, the class boundaries, and the class size. When you say class intervals or class limits, this refers to the groupings defined by the lower limit or the lowest value and the upper limit or the highest value. So the class interval of 10 to 15 would include the numbers of 11, 12, 13, 14, and 15. So the class intervals or the class limits are known as the extreme. Okay, so the extreme numbers, we have the number 10 and of course the number 15. The lowest or the lower extreme limit or extreme number is 10 and 15 is the upper or the highest limit. You also have your class mark. Your class mark is, or the class mark is the middle point. Okay, so the class mark is the middle point of a class interval. So it is obtained by getting the average of the lower limit and the upper limit. So like for example, in the class interval of 10 to 15, we just need to add lower limit, which is 10, and 15, and then divide it by 2. And it will give you a value or answer of 12.5. So the class mark or the middle score or the midpoint between 10 and 15 is 12.5. The next term that we need to be familiar with is the class boundaries. For continuous data like test scores, heights, and weights, the class interval of 10 to 15 is supposed to start from 9.5 and ends with 15.5. So these are more accurate presentation of class limits and they are termed as your class boundaries. Okay, so your class boundaries are the real true limits, okay, or the real true class limit of a certain or a given value. So the exact lower limit of 9.5 to 10.5 is 9.5, while 15.15 is the exact upper limit. However, your class boundaries are seldom recorded for discrete data. It's only recorded for your continuous data. So the last term that we need to be familiar is the class size. So the class size is the difference between the upper class boundary and the lower class boundary of a given class interval. So for a class boundary of 9.5 and 15.5, the class size is 6. And for paano natin nakuha yung 6? So we just need to subtract 15.5, no? We just need to subtract 15.5 minus 9.5, and this will give you an answer or a value of 6. Please do not forget the different terminologies that I presented a while ago, the class limit, the interval, and the class size. Okay, so let's discuss now your frequency distribution. Your frequency distribution, we have a group and your ungrouped frequency. So a ungrouped frequency distribution can be constructed by arranging the number from your highest to the lowest in a single column, usually in the first column. And the frequency or number of times each course is determined in this frequency distribution. So like for example, we have here your class intervals. In the first column is your class interval. We have here the tally and of course the frequency. Okay? So, in the class interval of 10 to 24, meron tayong isang na tally or a frequency of 1. And a class interval of 25 to 29, we have two tallies or a frequency of 2. Okay, so this is just a basic example of a ungrouped frequency table or a frequency distribution. In statistics, we are dealing with voluminous figures, voluminous data, or voluminous numbers. And one way of presenting a good data is with the use of frequency distribution or frequency table. In your research, next school year, sooner or later, you will be also constructing your own frequency distribution in presenting the demographic variables. Like for example, the age, the sex, the gender, the place of residence, and the monthly income of your respondents. So here are the steps in constructing or creating a frequency distribution table. This is now the application of the first lesson or the first concept that I have presented, the class limit, class size, class boundaries. Okay, so for the step number one, find the range. So in finding the range, or range is the difference, take note of our term, okay? So range is the difference between the highest score and the lowest score. So in a given ungrouped data or in a raw data, first you need to look for the range, no? Tignan natin yung highest score and the lowest score. The second step is to determine the class interval or the classes into which the data will be grouped. Okay, so example kanina, we have the class interval or class of 10 to 15, which includes the number of 11, 12, 13, 14, and 15. Step number 3 is to tally the scores into classes. Okay, so to illustrate the process in finding the range or in constructing your frequency distribution table, let's consider the following data. Okay, so suppose these are the achievement test scores of 40 students in biostatistics class. Okay, so kung bibilangin natin lahat to, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5. So in total, we have 40. Okay, these are the 40 scores of students in biostatistics. Okay, so if we will be constructing rather a frequency distribution table, we apply step number 1. In step number 1, ano yung hahanapin natin? Yung hahanapin natin dito is the range. Okay, so we need to find the highest score and subtract it with the lowest score. So the highest score is 93 and the lowest score here is 47. So 93 minus 47, this will give us a value or an answer of 46. The step number 2 is to determine the classes or the intervals into which the data will be grouped. Suppose that we want to have 10 classes. We then divide the range by 10. So, yung nakuha natin kanina is 46. So, 46 divided by 10, this will give us an answer of 4.6. Okay, of course, 4.6 ay merong decimal point. Our next thing that we need to do is to round this number to a whole number. So, 4.6, this can be rounded off to 5. Okay? Sa 5 or number 5. So, this is a number in the class width or the class size. No? So, yung 5 na nakuha natin, yan yung magiging class width or the class size. So, there are times na ang pwede natin makuha na class width or class size ay 4, 6, no? Or 7 or 3. Okay, so between odd numbers and even numbers. So, ano example natin ng odd numbers? We have your 1, your 3, your 5, no? Your 7, at yung mga numbers na hindi natin pwedeng i-divide ng 2 kasi hindi whole number ang magiging answer. So, between your odd numbers and even numbers, it will still best to choose what? It will still best to choose your odd number. Okay? So, we then choose the lowest class to be 45 hanggang 49. So, yung 45 hanggang 49 na lowest class will contain, no, the values of 46, 47, 48, and 46, 47, 48, and 49. Okay? So, note that the lower limit, 45, is a multiple class width of 5. Okay? So, yung mga susunod na classes natin ngayon, we have 50 to 54. Okay? 51, 52, 53, and 54. Okay, next we have your 55 hanggang 59, 55, 56, 57, 58, and 59. Okay, next we have your 60 to 64, 65 to 69. No? Kung mapapansin natin, between yung lahat ng classes na to would contain 5 values or 5 numbers. Okay? So, and see to it that your lowest class and your highest class, okay, yung lowest class natin, 45 to 49, highest class natin, 90 to 94, will contain the lowest score and your highest score respectively. Okay, so that's for your step 2, determining the class or intervals. The third step is to tally the scores into the classes. So this is the final step, is to tally into the classes and then find the frequency for each class. Okay? So in your step number 3, we need to create 3 columns. So the first column, andyan yung classes natin. Your second column, we have your tally. And the third or the last column is the frequency. Okay, so on our first column, on our first class, on the upper class, we have the 90 to 94. Meron tayo 2 students whose scores falls between 90 to 94. That's why our frequency will be 2. Okay, same with through with 85 to 89, 4, 80 to 84, 5, 75 to 79, 7, 70 to 74, 11. Okay? So note that your upper class, 90 to 94, covers the upper limit, and your lower class, no, 45 to 49, covers the lower limit or the most lowest limit. If you're going to get the sum or the total of the frequency, this will give you the total number of students included in this study, okay, which is 40. 40 students in the biostatistics class. Well, we also need to get the percentage distribution. So a frequency distribution can be converted to a percentage distribution using this formula. So percentage, okay, so percentage is equal to the frequency divided by the total number of frequencies multiplied by 100. So we also have here your cumulative frequency distribution. A cumulative frequency distribution is obtained by, of course, getting the sum of the frequency of a class and the frequencies of a lower class. So later on, I will present to you examples of uh, percentage and your cumulative frequency distribution. Okay, so this is a sample cumulative frequency table. Okay, so in your cumulative frequency, on the first column, andito yung ating class. Okay, on your second column, we have here your frequency. And the third column, we have here CF or your cumulative frequency. Okay, so kapag meron tayong given set of values, okay, so this still, ang example natin na to is the 40 students in biostatistics and here are their scores. No? Ito yung class ng kanilang scores, ito yung frequency ng kanilang scores. Okay, so on the upper class, 90 to 94, dalawa. 85 to 89, apat. 80 to 84, 5. 75 to 79, 7. Okay? So, kung bibilangin natin, ilang classes ba to? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 10 classes in total. Okay? So, we have 10 classes in total. Okay? So, since nakuha na natin yung class, na-compute na natin kanina yung class, alam na natin kung ano yung gagawin natin, alam na rin natin ang ibig sabihin ng frequency. Frequency is the total number of appearing values in a given set of class. Our problem here now is how to compute cumulative frequency. Although on this table or on this slide rather, kompleto na, no? nilagay ko na dito yung cumulative frequency. But you might be wondering, paano natin nakuha ang cumulative frequency? So, this is our tip or guide on how to get the cumulative frequency. First, unahin natin dito sa pinakababang frequency, unahin dito sa pinakababang class, on the lowest class, and on the lowest frequency count. Okay? So, ano ang nakuha natin? Ilan ang frequency on the class of 45 to 49? Frequency of class of 45 to 49, we have 1. So, yung 1, ilagay natin dito sa cumulative frequency table na pinakamababa. So, we just get the sum of the lower class, which is 1. Okay? After ito, we need to add the CF1 or cumulative frequency 1 to the next upper class. So, 1 plus 1, saan natin nagkuha yung 1? Of course, on this frequency, 1 plus 1 is equal to 2. Okay? 2 plus 1 is equal to 3. No? 3 plus 2 is equal to 5. 5 plus 6 is equal to 11. Nakuha na? So, yan lamang yung parang basis natin. So, that's the, kumbaga, parang diagram on how to get the cumulative frequency. Parang pa-zigzag lang, no? Get the sum, lagay mo dito, i-add mo sa taas, lagay mo dito yung sagot, i-add mo sa taas, lagay mo dito yung sagot, i-add mo sa taas, lagay mo dito yung sagot, i-add mo sa taas, lagay mo sa tabi yung sagot. And the same process will continue. 11 plus 11 is equal to 22. 22 plus 7 is equal to 29. 29 plus 5 is equal to 34. 34 plus 4 is equal to 38. And 38 plus 2 is equal to 40. And note that the uppermost cumulative frequency count should be the same with the total number of frequency. Okay? Para malaman natin kung tama yung ginawa natin na pag-compute ng cumulative frequency count, we need to compare with the total number of observation or the total number of frequencies. Nakuha? So that's how to compute for your cumulative frequency. Okay, so we are done now with creating your frequency table. Okay, so kapag familiar na tayo sa paggawa ng frequency table, we know already how to create the first column, which is the class size, no? The class interval, look into the frequency, the percentage, and the cumulative frequency. Okay, and of course, yung upper class limit and the lower class limit and other parts of the table. We are now ready to move with the histogram. So histogram is a pictorial representation of frequency table. So it consists of abscissa or the horizontal axis, okay? Horizontal axis, okay? And the ordinate or the vertical axis, okay? So your horizontal axis is your class interval. No? Yung horizontal axis natin is your class interval. And the frequency, no? Yan yung, the vertical axis, okay? Or the y-axis or the ordinate axis is your frequency. So kung titignan natin dito, okay, palitan ko lang yung aking ink. Okay. So on the class interval of 10 to 15, no? This is the class interval of 10 to 15, ilan yung frequency na pwede natin makuha is around 20. On the class interval of between 15 to 20, ilan yung frequency natin? 25. Between 25 and, 20 and 25, yung frequency natin, frequency count natin is 30. Okay, so that's how to create your histogram. So these are just few instructional videos that you can watch in the YouTube so that you will be more familiar on creating your histograms. Okay, so the next one is your frequency polygon. Your frequency polygon is a line graph, no? It's a combination basically of line graph obtained by connecting the midpoints, take note of that word, midpoints, of the top of the bars of the histogram. So in creating your frequency polygon, dapat ay gumawa muna tayo ng histogram or a bar graph. Okay, so your frequency polygon is also a useful device to show the values over successive periods. Okay, so the difference only between your frequency polygon and your histogram. Sa histogram ay pure lang, no? Puro bar lang sila, no? Puro mga ganito lang, mga bar graph lang yan. Okay? But in frequency polygon, merong line, no? Merong mga linya. Okay? At kung mapapansin natin, yung mga linya na to connects, no? In the mid-score or the middle point of each bar, okay? Or each histogram na na-construct natin. So, anong ibig sabihin ngayon nito, no? So, this means that in your frequency polygon, we are considering here the midpoint, no? We are considering or looking here the middle scores or the midpoint or the mid-score of each classes, okay? So, like for example, no, between the class of 145 centimeter and 150 centimeter. Okay? So, 145 plus 145 plus, di ko nakita. It's 140 plus 150. So, it's 290 divided by 2. And the middle score or the midpoint natin is 145. So, this is correct, no? So, yung gagawin natin dito in your frequency polygon, we just need to place period or dot between, dito sa gitna, in each one, in your each histogram. Okay? So, yan naman po yung gagawin natin. Pasensya na, medyo mahirap gumamit ng mouse. Okay? So after locating the midpoint, then we are now ready to connect the midpoint. So mag-draw ka lang ng straight line connecting the midpoint of each histogram or each bar graph na na-connect mo and then end it. Okay? So this is now your frequency polygon. Nakuha? So yan po yung frequency polygon. So it's very important for all of us to be familiar with your class limit, your class size, your class mark, your class interval, and your class boundaries. So again, no, here is your steps in making a frequency polygon. Take note that that represents the x-axis by using a class mark of the class interval, and your represents the y-axis using frequency of the class interval. After placing the class mark and frequencies in x and the y-axis, and of course constructing your histogram, you need to plot the class frequency by means of line, and then connect the points of lines and create additional class for both ends of the distribution to close the polygon. Okay? So, kung babalikan natin yung picture kanina, meron yung connecting line between each mid-score or class mark of each polygons, or sorry, of each histogram or each bar graph ay merong starting point and ending point. So these are just examples of other graphical presentation, no? A bar graph. Take note that your bar graph is useful only in presenting nominal and your ordinal data. So, ano yung mga examples natin ng nominal data? We have your age, the sex, okay? Place of residence, the year levels, mga ganun. That's the lowest. And your ordinal data, those are data that can be grouped or ranked. Okay, so examples natin, we have your faculty rank, the stages of cranial lacerations, no, etc. We also have here your ogive curve. Your ogive curve or your cumulative frequency polygons is a graph of a cumulative frequency plotted against the upper class boundary. So the upper class boundary is the midpoint of the upper limit of a class and a lower limit of the next class. So in your ogive curve, kailangan natin dito yung midpoint. Okay, so example for a class of 40 to 49, which has been reflected in the lowest class, no, sa ating frequency table kanina, with a cumulative frequency of 1, and the upper boundary is 49.5, and that the class of 90 to 94 has a cumulative frequency of 40, and the upper class boundary is around 94.5. So in your ogive curve, ano nga ba ang ogive curve? So parang ganito yung ating ogive curve, no? So kung mapapansin natin dito sa horizontal axis or on the x-axis, yung mga scores or yung mga values natin dito is the upper class limit, no? It's the upper class limit. For example, ito supposed to be is 40 to 49 pero naging 49.5, 54.5, 59.5, 64.5, 69.5, etc., etc. And of course, in your y-axis, no? On the vertical axis, we have here your cumulative frequencies. Okay, so ang gagawin lang natin, we just need to plot, no? Kung saan papasok, no? For example, your first class 45 to 49 is si cumulative frequency niya ay 1, and of course the other values will just continue. So ang gagawin lang natin dito, ibatog tayo lang, okay? Dito sa baba, dito sa dito sa horizontal na axis natin to the vertical axis of each cumulative frequency. So after natin siya na-plot, then we need to draw now a line, no? So that is now your ogive curve. So your ogive curve is similar to a line graph. Okay, so this is just a few tips or the steps in conducting or constructing a cumulative frequency polygon. So first is you need to represent the x-axis and the y-axis, and then you need to plot the above of the upper exact limit, which corresponds to each cumulative frequency count or the CF count, and then connect the points by lines. Okay, so again, an example of your ogive curve. So the next example of a graphical representation of a given set of value that can be applied in statistics is your pie chart. So a pie chart is a data that may be presented through a pie chart or a pie in which the area of the circle represents the whole set of data. So the area is divided proportionately among the groups that represents each value or that represents each data. So here's the simple steps in making your pie diagram or your pie chart. So suppose that we want to create a distribution table of midwives in region X. So we have the localities of San Pedro, San Juan, Santo Tomas, and San Vicente. The total number of midwives in San Pedro is 1,600, in San Juan 1,300, in Santo Tomas 1,150, and in San Vicente is 270, with a total of 4,320 midwives in region X or in region 20. So this is just a hypothetical example. So in your step 1, we need to divide, no? In your step 1, we need to divide the number or the midwife per locality, okay, by the total number of population. So for example, in San Pedro, 1,600 divided by 4,320, and this will give us a proportion of 0.3704. So yun yung sagot kung paano natin nakuha yung column 3, which is the proportion. So same with San Juan and the rest of the locality. 1,300 divided by 400 divided by 4,320, the proportion is 0.3009. 1,150 divided by 4,320, 0.2662, and the rest will continue. Okay? So if we're going to add this proportion, this will give us exact value of 1.00 or 1.0. Nakuha. Okay. So step number 2 is to multiply the proportion by 100. Okay, we multiply the proportion by 100. Why do we need to multiply the proportion by 100? Because we want to get the percentage per locality. So 0.3704 multiplied by 100 is 37.04. 0.3009 multiplied by 100 is 30%. No? 0.2662 multiplied by 100 is 26.32. So, ito na po yung percentage. Step number 3 is to multiply the proportion by degree or to multiply the proportion by 360 degree. You might be wondering, no, kung bakit 360. 360 degrees, no, ito yung measurement natin ng isang buong circle. Take note, we are constructing a pie diagram or a pie chart. And of course, a pie diagram or a pie chart is a circle. Okay? Kaya we need to multiply by 360. Okay? In your step number 3, we multiply the proportion, okay, by 360. Okay, so 0.3704 multiplied by 360 is 133.34. 0.3009 multiplied by 360 is 108.324. 0.2662 multiplied by 360 is 95.832. And 0.0625 multiplied by 360 is 22.5. If you're going to get the sum of the degree, total number of degrees per region or per locality, this will give you a 360 degree na sagot. Okay? Step number 4 is, ayun, please don't forget your protractor. Okay? Step number 4 is to use a protractor in labeling or in constructing a pie chart or your pie diagram. So just draw first a circle and then locate each point, no? Locate each point or each degree that corresponds to your computed degree per locality. So yan yung paggawa natin ng pie chart or your pie diagram. I think this is the last. So, we have the stem and leaf display. So stem and leaf display was suggested by Tukey, and this is an innovative technique for summarizing data that utilizes characteristics of frequency distribution and histogram. So, in your stem leaf display, meron tayong tinatawag na stems or stem, meron tayong tinatawag na leaves or leaf. Your stem represents the class interval, and your leaf are the strings of values within each class interval. So, for each stems, no, or for each interval, we arrange the last digits of observation from lowest to the highest, and the leaves reflects the values of observation from which it is easy to note their size and their frequencies. Okay? So this is your example of a stem leaf display of a systolic blood pressure of 67 smokers. So in the first column, again, andito yung interval natin. Pero kung mapapansin natin, yung pag-create natin dito ng interval is pababa, no? Or the classes rather is pababa, no? From lowest to highest. Okay? Pwede ring from dito sa baba is pataas, no? From lowest up to highest, pwede rin yun. So that would just depend on your preference, kumbaga. Okay? So these are the stems, and these are the leaves of observations, no? So kumbaga parang ito yung tally, no? Ito yung tally natin, and this is the frequency. Okay? So in systolic BP between 90 to 99, merong dalawang pasyente, dalawang episodes or two episodes, 4 episodes, 6, and your 8 episodes. You get the frequency 1, 2, 3, and 4. 4 observations that falls under systolic BP of 90 to 99. And the rest will follow. Okay, so I think that's the end of my presentation with regards to the graphical presentation of the data. So these are just simple and basic basic application, no? The importance of your graphs, tables, figures is to create a visual representation in order for your audience to understand and better understand, as well as to to comprehend, better comprehend the data that you were able to collect. Nakuha? So, thank you very much for your time. And if you want to be more familiar with in constructing your tables, figures, or graph, feel free to visit the sites that I am sharing. Again, this is Bertie Alcograd, your instructor. Thank you very much for listening.